Okay, so how the lenses of cameras are designed, or the thickness or the coating on the top of lenses, how it is determined. Okay, so that is what we had seen yesterday. Um, so I remember there were at the end 36 around students. So yeah, so let me we will recap all that again um, very quickly, and then we will move on to applications and some questions and numericals, if possible. Okay, otherwise we will discuss that in our next lecture. Okay, so the important topic is interference of light, what we studied. So it is a phenomena, optical phenomena, in which there will be a superposition of different components of light. Okay, interference is a optical phenomena in which there is superposition of different components taking place. So when there are two or more waves with a constant phase difference with same intensity and same amplitude, and if they are traveling in a medium, okay, so the resultant amplitude will be the summation of all the vector sums of the each amplitude. ओके, सो दिस प्रॉपर्टी इज नोन एज इंटरफेरेंस ऑफ लाइट कि दो अगर दो या दो से ज्यादा वेव्स हैं फोटोन के तो वो एक दूसरे से इंटरैक्ट करते हैं अगर वो सेम फेज के हैं सेम फेज डिफरेंस है उनमें तो बेसिकली दे आर कोहेरेंट इन नेचर ओके कि सिंक एक दूसरे से सिंक में है जैसे एक का वेव दोनों वेव्स जो हैं लाइट के so all the waves are in sync all the sinusoidal wave और crest के ऊपर crest और trough के ऊपर trough ऐसा होगा ओके सो इंटरफेरेंस दो प्रकार का होता है कंस्ट्रक्टिव इंटरफेरेंस और डिस्ट्रक्टिव इंटरफेरेंस तो जब भी हमें ब्राइट कलर्स दिखते हैं उसका रीजन है कि वो लाइट कंस्ट्रक्टिवली इंटरफेयर करता है तभी हमें उसके ब्राइट कलर्स दिख रहे हैं और अगर वो 180 डिग्री आउट ऑफ फेज है अगर दो वेव्स तो दे विल कैंसल ईच अदर आउट है ना तो ये भी हमने पिछले बार आई थिंक 2 3 लास्ट वीक हमने डिस्कस किया था कि if the two waves are 180 degree out of phase then they will have destructive interference okay so ऐसे उनका सुपरपोजिशन होता है सो कंस्ट्रक्टिव इंटरफेरेंस की हमने प्रॉपर्टी देखी तो वेरी इंपॉर्टेंट प्रॉपर्टी ऑफ अ कंस्ट्रक्टिव फॉर द कंस्ट्रक्टिव इंटरफेरेंस इज the path difference between the path difference between the two waves है ना अगर दो waves हैं उनके बीच का path difference कैसा होना चाहिए it should be integral multiple of the wavelength then you will get constructive interference okay the path difference should be equal to integral multiple of wavelength so path difference is equal to n lambda so this is condition for constructive interference in terms of phase difference so phase difference should correspond to 2 pi radians okay so phase difference will be having 2 pi 4 pi and so on multiples of 2 okay similarly the destructive interference का condition mathematical condition क्या होगा so here you can observe if this wave are slightly आउट ऑफ फेज विद ईच अदर है ना हम फेज इन फेज कब कहते हैं अगर हम ये दो फिगर कंसिडर करेंगे तो इस वेव का जो अपर हाफ है राइट और द क्रेस्ट इज देयर it matches with the crest of the other wave so then we say these two waves are in phase equal to each other right equivalent to each other so if they are slightly offset है ना अगर उनमें offset है so that means they will have a phase difference okay so whenever there is a phase difference of pi और उसके odd multiples pi 3 pi 5 pi and so on then you will get destructive interference है ना जैसे आप देखोगे कि यहाँ पे एक का crest है दूसरे का trough है so like this is +1 this is -1 so if that gets add up then the resultant is 0 so the condition for path difference for the two waves is 2n plus or minus 1 lambda by 2 path difference between the two waves is odd integral multiple of the half of the wavelength. Odd integral multiple of the half of the wavelength. And the phase difference will be equal to pi or 3 pi or 5 pi. Okay, so these are important conditions for constructive interference and destructive interference of light. हमने उसके बाद conditions for sustained interference भी देखा था. So one of the important properties that the two interfering beams should be coherent to each other. They must have constant phase difference. The light should be monochromatic in nature. That is of single wavelength, single color, single energy की होनी चाहिए. Or the interfering sources must have same amplitude. ये भी हमने लर्न किया था, डिस्कस किया था. ओके, और इंटरफेयरिंग सोर्सेस एक दूसरे से नैरो भी होने चाहिए और पास भी होने चाहिए, सो दैट द टू वेव्स आर क्लोज टू ईच अदर टू इंटरफेयर. तभी वो इंटरफेयर करेंगे. अगर दूर दूर होंगे तो वो मिलेंगे ही नहीं, दोनों फोटोन बीम्स, है ना. तो ये भी हमने डिस्कस किया पहले. We have also discussed further different ways to produce coherent wave. One is division of wavefront and other is division of amplitude. In division of wavefront, you basically allow the light to pass through two different slits. So Young's double slit experiment is a example of division of wavefront. आपने थोड़ा 12th में पढ़ा होगा कुछ बच्चों ने. Division of amplitude is whenever a beam is passed through partially reflecting surface or thin film or mirror. This is known as division of amplitude. Okay. Again, then we had discussed about Stokes' law. Okay. So, can somebody tell me about Stokes' law?
When wave travels from rarer to denser, there is a phase change of pi.
Very good. Very good. So whenever a light rays are traveling from a rarer medium to a denser medium, it strikes from the denser medium. The reflected light will be out of phase. Okay, so यहाँ आप incident wave देख रहे हैं. So which is getting reflected at the top of the surface, the top of the block, uh, and the reflected light is out of phase with the incident wave. And as some of the light is getting transmitted inside the block, which is having which is in the denser medium, so the light in the denser medium, if it is in the same medium, then there is no phase change. That is, they are in sync with each other. Both the waves will be in sync with each other. And if the um, electromagnetic wave is coming out, that is from the denser medium to the lighter medium, then also it will be in phase. So this is what Stokes' law tells us. So there is always a phase change of pi or path difference lambda by 2 occurs when light waves are reflected at the surface of the denser medium. And there is no phase change occurring when the light waves are reflected at the surface of a rarer medium. Okay. So these are important things like prerequisites before we dive into the derivation of interference due to thin film of uniform thickness. Okay, तो ये हमने पहले डिस्कस किया था. So all you need to remember here is the end formula, जो final derivation के जो formulas आए हैं, that you need to remember. Okay. So interference due to thin film of uniform thickness, उसके example है oil on the water surface, so bubble are also examples of thin film. Okay, so आपने observe किया होगा whenever oil is floating on water, you will be able to observe different colors. Okay, or on the soap bubble, if the soap bubble is in the sunlight, you will observe colorful soap bubbles. So I'm sure you all might have observed this. Okay, so so beautiful colors are colorful patterns are seen whenever oil is spread on water. Bright colors are seen. So these are surface effects, or interference effect occurring on the surfaces. Okay. So then we had discussed about interference due to thin film. Okay. So हमने पिछले हफ्ते में देखा था कि here let me play the animation for you. So you can see we have a thickness C of the thin film with the reflectance index mu, and if incident ray AB is striking at point B, um, so making an angle I with the normal, so you are getting a reflected light and a refracted light. So the reflected light R1 is 180 degree out of phase with the incident ray AB. At point C, the light is again getting transmitted out and getting reflected back in the medium, and that is coming out as ray R2. Okay, so this is what we had. This is our first case. Okay, so what happens is the ray R1 and R2 will combine constructively or destructively. Okay, so okay, so you have seen this figure, and let me now go back to our okay. So here R1 and R2 rays are interact with each other or interfere with each other constructively and destructively. Okay. So and there is another possibility. You can observe there are rays T1 and T2 at the bottom of the thin film. Okay, below the thin film. So they also will interact with each other. Okay, T1 and T2 will also interact with each other and will create an interference pattern. Right? So now there will be two effects. One will be reflected signal, and also there will be effect due to transmitted light, transmitted rays, isn't it? So we have two cases. One is for reflected system, other case for transmitted. So we have derived equation for both of them. We have derived the equation for the reflected system. Like we have seen all the steps. Similar steps are followed for the transmitted rays of light. Okay. So we have defined this, and the important first step is we can get the path difference between R1 and R2. Okay. So path difference between R1 and R2 is by the time the ray R1 reaches point N from B, the other ray has reached point D. Right after reflecting inside, refracting inside, and getting multiply reflected. Then so the difference path between R1 and R2 will be path reflected in the film minus path Tn. Okay. So you have delta path difference is equal to mu Cc plus Ct minus Tn. And then we figured EMC, we applied trigonometry, laws of trigonometry, and EMC sine of R is equal to Cm by Cc. Cm is nothing but thickness of the film, dt. So Cc becomes T by cosine R. Now we are trying CMD. Basically, from that equation here, mu is equal to Cc minus An. We are going to find out all the substitute these elements in terms of known parameters like thickness, angle, refractive index. Okay. So these now consider triangle MMD. You will get similar CD is equal to pi by cosine R. Okay. So you will substitute that in the first equation. There are becomes 9 times 2 by cosine R. Okay. Minus now we will try to find out value for EN in terms of mu, thickness, and all. Okay. Or angle of incidence or angle of refraction. Then we have for B and we are considering triangle A and D. Okay, so the sine of I there is equal to B n by D. So B n comes on B D sine I. You can write down as B L plus M D. Okay, so the join B and D, B M would be T tan R. So same and will be equal. So you substitute that in the equation for B and I'm jumping the steps because we have already discussed all these things twice. So this is the third time I'm repeating this. So I hope everyone has followed all these things, or you can read the slides. Okay, so some of you have taken the notes. So those who don't have, please ask your friends and you can get it from them. Okay, and I'm going to share all these content later. Once our discussion on these topics is over, then I'm going to share this content with you all. Okay, so B and N equal to 2 tan R sin R. Okay, so again हमने sin we try to convert everything in terms of mu. Okay, so we multiply by the numerator and denominator by sin R. That sin I by sin R becomes mu, and so your the second term becomes 2 mu t sine square r by cosine r. Then you can take 2 mu t common, cosine r also common. In the bracket you have 1 minus sine square r. So 1 minus sine square r you can write down as cosine square r, and 1 cosine can get cancelled out. So it simplifies to part difference simplifies to 2 mu t cosine r. Okay, and for the reflective system, since it is reflected from a tensor medium, from the Stokes law, we have to add path difference of lambda by 2. So the total path difference becomes 2 mu t cosine r plus or minus lambda by 2. And then for constructive interference, this path difference should be integral multiple of wavelength. So you equate it to 2 mu t cosine r plus or minus lambda by 2 equal to n lambda, so which is equal to 2n lambda by 2. Taking this lambda by 2 on the right hand side, you will get this equation. Okay, so you will get the equation 2 mu t cosine r 2n plus or minus 1 lambda by 2. This is the condition for constructive interference for the reflected system. Okay, please be careful. This is the condition for constructive interference of the reflected system. Condition for destructive interference or minimum will be, for the dark point part difference will be odd multiple of lambda by 2. So you will equate the same thing, 2 mu t cosine r plus or minus lambda by 2 equal to 2n plus or minus 1 lambda by 2. So lambda by 2 you will take it to the right hand side. You will get 2 mu t cosine r 2n into lambda by 2. So 2 and 2 will get cancelled out. So 2 mu t cosine r equal to n lambda. So this is the condition for destructive interference of reflected system. Okay. Now, similar logic is followed for the transmitted system. Now, here we are going to consider T1 and T2. So, you follow the same logic and you try to compute Ck here. Instead of you had Bn, so you will have the path difference of, uh, by the time this ray is reaching point K, this other ray is reaching traveling CD and DE. You know? So mu times CD and DE minus CK will be the path difference, and you solve for it basically. And in the similar fashion, you will get 2 mu t cosine R equal to 2n into lambda by 2n lambda by 2 or n lambda. So condition for constructing here, lambda by 2 term is not added because the reflection is in the same denser medium. So Stokes' law will not be applied here. Okay. So, and you can observe this condition, and condition for destructive interference becomes 2 mu t cosine r 2n plus or minus 1 lambda by 2. So both these conditions are exactly vice versa of the reflected system, as some of you had observed this yesterday. Okay. So these are conditions, criteria for interference of light due to which system? Somebody?
Transmitter.
Transmitted.
Transmitted system, and it is exactly reverse of reflected system. Okay, while solving the numericals, while solving the problems, be careful, read the question carefully. If it is a reflecting system or transmitted system, you have to use the formula accordingly. Okay, so be careful while choosing the which formula to be applied. Okay, and then yesterday we have moved on to a very important phenomena of interference of light in the wedge-shaped film. So it has a lot of applications. It has a lot of applications in it. Okay. So any questions anybody's having so far before we move on further?
No, sir.
Okay, perfect. Still, any girls, any boys, any questions? आपको
Yes, sir.
especially those who were absent for last few days. Harshi, who's Harsh or Harshi? I don't know name. He had messaged me.
Yes, sir, understood.
Okay, 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 perfect. Very good, everyone. So please feel free to ask me any questions now or also later. Okay, and then we can discuss one-on-one as well or in class also. So feel free to ask. So let us see this animation interference due to wedge-shaped film. So whenever two surfaces making an angle theta, two glass plates, for example, so how the light will be scattered from it. Okay, so here the incident ray AB strikes at point B and the light is getting reflected back, R1. From B, some light is getting refracted inside at point C. Again, it is getting reflected back in the medium. And from the inclined surface, it will come out as ray R2. So these rays R1 and R2 will combine constructively and destructively. Okay, and they will create a very interesting interference pattern. Okay, so this is the interference due wedge shaped film. Okay, I hope you have understood this figure. Okay, so here the only difference is instead of a thin film, you have the thickness of the film is changing with respect to the distance at an angle theta. Okay, so that makes things slightly different than earlier.